Carbon capture and storage (CCS) is the need of the hour due to rampant climate change. My name is Anthony Rozario, a student of the Department of Geology at St. Xavier's College, Mumbai, and today I will be talking about a very important yet unexplored aspect of CCS, that is, carbon capture and storage in the deep ocean. Carbon capture and storage in the deep ocean utilizes the layered nature of the ocean. In this method, typically carbon dioxide is injected directly into the water column below the thermocline, which is a transition zone between the warm mixed upper layer at the top of the sea and deeper lower waters which are undersaturated carbon dioxide. The warm upper layer is saturated in carbon dioxide. This layered nature of the ocean is due to density variation in the seawater. The amount of CO2 that can be stored in seawater is dependent on the nature of CO2 in seawater. The density of CO2 in seawater increases with depth. Up to 2500 meters, liquid CO2 is lighter than regular seawater and will rise. After 2500 meters and before 3000 meters, liquid CO2 is neutrally buoyant, meaning it will neither rise nor sink. After 3000 meters, CO2 will sink to form liquid carbon dioxide lakes. The layered nature of the ocean as well as the density variation are what enable us to store carbon dioxide in the sea, as well as they prevent vertical mixing of the CO2 into the ocean. Acidity is a particular problem introduced by CO2 though, because CO2 reacts with water to form carbonic acid, which can have a drastic effect on life nearby. CO2 also reacts with seawater at great depths to form solid CO2 hydrates, which are denser than seawater and also dissolve at a slower rate than pure CO2. Deep depths in the ocean are defined as a depth of below or equal to 500 meters, and it typically has a hydrostatic pressure of around 5 megapascals and a temperature of around 4 degrees Celsius. In order to transport CO2 to these depths, pipelines can be used and ship tankers can be used as well, and the final deposition can be done via manifolds or deep sea drones. There are many methods of sequestering carbon dioxide in the deep ocean. All of the methods rely on the properties of CO2 in the deep ocean. The methods are: Method 1, as a gas. As a gas, CO2 is released at around 500 meters depth. In this method, the goal is to let CO2 dissolve as fast as possible as it rises up. In order to minimize the time taken for dissolution, so that CO2 does not escape back into the atmosphere, CO2 diffusers are used to make the bubbles as small as possible. At these depths, CO2 hydrates are also likely to form on the CO2 bubbles, and in order to minimize the surface area on which those hydrates can form, the CO2 diffusers are used as well. In this method, liquid carbon dioxide is injected directly into the water column below 1000 meters depth, which marks the bottom of the thermocline. In this method, atmospheric escape of CO2 is less likely due to the increased density of CO2 and seawater and the thermocline above it, as well as the greater depth. In this method, CO2 diffusers are also used in order to avoid a localized low in the pH, and so it shouldn't affect any animals close by. In this method, a dense plume or a dense sinking current is made by combining CO2, liquid CO2, CO2 hydrates and seawater. Another way to make a dense plume is to combine liquid CO2 and crushed limestone. This method of making a dense plume also neutralizes the carbonic acid that is generated by the CO2, as limestone is CaCO3. And there is another method known as gas lift advanced dissolution system. In this method, there is an inverted U-shaped pipe. The CO2 is injected at the shallow end of the U-shaped pipe, and it mixes with the seawater inside the pipe. It makes the seawater more dense. This forces the CO2 enriched water to move up and out of the inverted U-shaped pipe and into the deeper oceans. Method 4 is CO2 lakes. This is a long-term method of CO2 sequestration. In this method, CO2 is injected below 3000 meters depth in an enclosed space like a trench or a basin. In this method, hydrate formation is very desirable because hydrates retard the dissolution of CO2 into the sea. So, an enclosed space like a basin or a trench where strong currents, deep sea currents are not present are preferred. Dry ice or solid CO2 is denser than seawater and will sink rapidly to the bottom of the sea upon introduction. But the process of making dry ice from captured CO2 is quite expensive, hence this method is quite cost ineffective. These are the various methods of carbon sequestration in the deep ocean. Captured and compressed CO2 is first brought via pipelines, and via pipelines the ships can be refilled, and those ships can deposit the CO2 via manifolds. Those ships can also fill up rigs, also take CO2 to rigs which can deposit CO2 lakes, and manifolds can extend directly from pipelines to deposit a sinking plume which is deposited below 3 kilometers or 3000 meters depth, or above 3000 meters depth a rising plume is deposited. The dense emulsion of CO2 and limestone can also be transported via manifolds to the deep ocean. The effects on life due to CO2 are drastic. The organisms that are most affected by CO2 are invertebrates, and among them deep sea squids are the most affected. Deep sea vertebrates are not as affected, but CO2 has an anesthetic effect on all life, and it also raises the acidity of their blood. Although some organisms have been shown to adapt to several natural CO2 lakes that are present near the coast of Japan and Hawaii. There are a lot of benefits to this method of carbon sequestration. First of all, the amount of CO2 that can be stored is in the thousands of gigatons, and that is one of the greatest methods of CCS. It makes it, and this is with current technology. And a lot of the transport infrastructure that is required for it can be easily modeled after LPG, liquefied petroleum gas pipelines and tankers, as well as natural gas pipelines and tankers. And and a lot of the small scale projects have been already conducted. A lot of experiments have been conducted in the deep sea to study the effects on life, etc. The scale that has been calculated recently is also massive. It's centennial to millennial scale, hundreds to thousands of years. It helps to upset the current anthropogenic release of CO2. The drawbacks are also quite as numerous. First of all, the method is very costly. Second, there have been no large scale projects conducted yet. There were 2 projects planned, but the first one, the one that was planned to be conducted off the coast of Hawaii, was cancelled because the research team didn't commit to proper public outreach, and they didn't due to that which spread public misinformation, as well as the public were not as aware about the topic. This led to very widespread protests which shut the project down immediately. There was also another project that was planned to be off the coast of Norway, and this project was also shut down because Greenpeace had shut it down. And another drawback is that life is drastically affected by it, and there is a lot of energy consumed by this method by the pumping mechanism, etc. And this is the biggest drawback. A lot of the research is very old. Aside from the energy requirements and the time scale that is calculated, most of the research is nearly 20 years old at this point, and new research is really required. And there is a legal issue. One of the London protocols prohibits dumping of CO2 into the ocean. So that is there. A bunch of the recent developments are that hydrate formation is being studied on bubbles, on the CO2 caps of CO2 lakes as well. And 3 sites in particular were surveyed for in South China Sea for their sequestration potential as well. And I like to say that a lot more research is required on this topic, as the research is very old, and it's very important that public are aware of this topic so that more research is conducted, especially because of the legal issues. Because this is one of the most potent methods of carbon sequestration, and more awareness will help to overturn those legal issues and help in carbon sequestration as a whole. And yeah, the references are included in the description as well as in the next 2 slides. Thank you for watching.